Hi, and welcome to the section, Application of Deep Learning in Text Mining. In this section, we will learn about pre-processing of textual data and extraction of sediments, analyzing documents using term frequency inverse document frequency, performing sediment prediction using LSTM network. Now we move on to the video, Pre-processing of Textual Data and Extraction of Sediments. In this video, we will process a tabular format of 1 token per row. We will use Jane Austen's best-selling novel, Pride and Prejudice, published in 1813, for our textual data pre-processing analysis. In R, we will use the Tidy Text package by Hadley Wickham to perform tokenization, stop word removal, using predefined sediment lexicons, term frequency, inverse document frequency matrix creation, and to understand pairwise correlations among n-grams. Open the RStudio. Here you can see that I have already imported preprocessing.r file from the code bundle. We will first load the required CRAN packages and the required text using these selected library functions. Now, perform tokenization to restructure the 1 string per row format to a 1 token per row format. Here, the token can refer to a single word, a group of characters, co-occurring words, sentences, graphs, and so on. Currently, we will tokenize sentence into singular words. Then, remove the commonly occurring words such as the and, for, and so on using the stop words removal corpus. From line number 20 through 30, we extract and visualize the top 10 most occurring words across all the 61 chapters from the Pride and Prejudice book. Now, click on the Zoom button to see the result in better resolution. This image shows the top 10 common words from the Pride and Prejudice book. Go back to our RStudio. Extract sediments at a higher level that is positive or negative using the Bing lexicon. By using this ggplot, we visualize the sediments across small sections of text. Now, add this selected block of code into our console tab. Now, click on the Zoom button to see the result in better resolution. This image shows the small sections of text from the Pride and Prejudice book. Go back to our RStudio. Now extract sediments at a granular level, namely positive, negative, anger, disgust, surprise, trust, and so on, using the NRC lexicon. Using this highlighted ggplot, we visualize the variation across different sediments. Add this highlighted block of code into our console tab to see the desired output. Here, you can see the result of variations across different sediments. Go back to RStudio. Extract the most occurring positive and negative words based on the Bing lexicon and visualize them. Click on the Zoom button to see the better visualization of our result. From this image, you can see the top 10 positive and negative words. Next, generate a sediment word cloud by using this highlighted line of code. In this image, you can see the negative and positive words. From line number 32 through 59, we demonstrate high and granular level sediments using 2 widely used lexicons, Bing and NRC. Extract the chapters and perform tokenization. Let's analyze sediments across the chapters of the book. In line number 61 and 64, extract the chapters and perform tokenization. In line number 66 through 68, we extract the set positive and negative words from the Bing lexicon. Get the count of words for each chapter using this word counts line of code. Next, extract the ratio of positive and negative words using this highlighted block of code. Generate a sediment flag for each chapter based on the proportion of positive and negative words. Add all these selected functions into our console tab to see the desired output. From this output, you can see chapter-wise sediment tagging is performed using maximum occurrence of positive or negative words from the Bing lexicon. Out of 61 chapters, 51 have occurrences of positive lexicons, and 10 have more occurrences of negative lexicons. In this video, we have performed pre-processing of textual data and extraction of sediments.